Hello and welcome to this short presentation on the floating offshore wind super test project supported by the Supergen ORE Hub and the Offshore Renewable Energy Catapult. My name's Tom Davey at the University of Edinburgh, and in this project I'm collaborating with Martin Han at the University of Plymouth and Saishuai Day at the University of Strathclyde. And between us we represent three laboratories, all concerned with the physical testing of floating wind devices, being Flowwave at Edinburgh, Coast at Plymouth, and the Kelvin Hydrodynamics Laboratory at Strathclyde. And within this project, we're looking at the challenge associated with software in the loop systems. Now, a software in the loop system is essentially what we use within a hydrodynamic test laboratory, i.e. a test tank like the three facilities in this program, and we use that to simulate the aerodynamic load in a hydrodynamic test environment. So essentially the wind thrust upon a floating wind turbine model. This has been previously explored in a variety of different ways, but they're all formed of the same basic elements. That is, we have a real-time loop, which is measuring the model motion, computing a virtual rotor thrust, and then giving us a load which we then have to apply to the model. And this uses a variety of modeling techniques, but what we're really interested here is the interfaces between this. So having calculated a certain load, we're then outputting that and physically applying it to a model. Now, in Plymouth and in Strathclyde, i.e. the Coast and KHL laboratories, we are using a thruster-based system. So this could be akin to a motor on a drone, for example. While in Flowwave, we're using a mechanical line actuator. So essentially a sort of very lightweight force-controlled winch. And what we're trying to do within this project is we're quantifying some key challenges, such as the force fidelity. The loads actually at tank scale are quite small, so are we actually generating these correct loads? Are we adjusting them fast enough? And latency, which is critical given that at, say, 1 to 50 scale, we're operating about 7 times faster than reality. And the key to note here is that we have this in the loop element means that at all times we are feeding the instantaneous motion of the platform back into the controller. So essentially we're getting that coupled hydrodynamic aerodynamic motion. So within the project, what we're trying to do is take the techniques which have been developed up to this point and standardize them and benchmark them. And then this allows us to then look at how we modularize the components. So, for example, we might have a surrogate model which is calculating the aerodynamic loads. We want to make sure those surrogate models can speak to a variety of different hardware. So whether that's the thruster that I mentioned before or the winch system as used in Flowwave. And to do that, we really need to identify the interfaces and features between these components, but also understand how that relates to industry usage and certification bodies. So within this project, we have our industrial partners in the form of Marine Power Systems, MPS, and their Pelaflex floating and deep water wind technology. And we also have Lloyd's Register representing classification and certification societies. So in order to do this, we want to look at how we define our common environmental conditions and our benchmarking cases, so that we can then look at, before we actually move on to the more complex software in the loop problems, and we see a demonstration of that in Plymouth and Flowwave in the videos here, we can also look at making sure that we've got a benchmark of these model behaviors. And also, in response to industry challenges, we're looking at transit and towing as well. So we're also looking at how these facilities can best explore that pre-operational phase. And one of the key things we're leaning on here is round-robin testing. This is something we've done previously in the Marinette 2 project for wave and tidal. And within that, we're going to be deploying both MPS's technology and a reference platform across all three facilities. And we'll be doing that over the course of summer 2026. And within that, that allows us some common threads. That looks how we benchmark the case with no wind, then how we apply 3 different software in the loop methods, looking for commonality and any disagreement or improvements required between them, and also moving on to elements such as how we model extremes with design waves, and finally the transit performance, i.e. the towing performance. So from this, we're getting a variety of deliverables. That includes elements on protocols for how we should modularize the software and hardware system, the benchmarking data sets, which will be for the reference platform, will be freely available. And then also looking at our towing technique, appraisal and extreme testing methods. And that is, I've mentioned, that's reaching out to both developers, like our partners at MPS, certification bodies like Lloyd Register, and also providing guidance for the communities. And within that, we're really hoping to actively engage with future guidance and standards. So thank you for your time, and I welcome any interest in this project going forward.